The first part of what we're going to be looking at today is understanding real numbers. And so just as I've written out here for you guys here, real numbers are any number that is positive, negative, or zero. And so just something to note here is that zero is not a positive or a negative number. So it's not considered positive or negative. It's kind of, you can think of it generic, as a generic number, I guess. So it's wouldn't be labeled as positive or negative, but anything that you can call a positive or negative number, like 1, 2, -4, -30, those would be considered real numbers. And a way that we can know it's a real number is we can represent it on a number line. So just as I've written right here. So I can represent this by a number line. And a number line looks something like this. So you guys have probably seen it before. Maybe in your other classes, in your other math classes, but a number line is basically just a horizontal line just like this one, and it has little hash marks here, and they represent different numbers. And so what we have here is we have 0 here in the middle, and that acts as our divisor, I guess, because like what I told you about how we don't think of 0 as a positive or negative number, how it's neutral. So it acts as the division between the positive numbers. Okay. And our negative numbers. And so there's always going to be two sides like this, and the positive numbers are always going to be the ones that are to the right of 0, and our negative numbers are always going to be the ones to the left of 0. And so our little neutral number here, 0, we call that on the number line, and you'll see this word sometimes in the book, they call it the origin. Okay, so again, positive numbers are to the right of 0, negative numbers are to the left. And just so that you guys know, just a quick thing to remember is that when you're reading a number line, when you're trying to read this, the numbers get bigger as you go to the left here. So as we go to the left, we are getting closer to 0 on the negative side, and if we just kept even scooting more over to the left, you see how we keep getting towards the positive numbers, the even bigger positive numbers. And so if we wanted to see how the numbers decrease, they decrease going this way, going towards the left side. Okay, so if I use this example of 5, it would be 5, 4, 3, 2, 1, getting to 0, and then we start submerging into the negative numbers. Okay, so it increases going from left to right, decreases from right to left. So let's look at an example of a question they might give you. So they might ask you to graph the following numbers on a number line. So you're given -1, 2, 5, 0, -3, -3.75, and 7/3. And so let's go ahead and graph this out. So I'm going to label our number line 0, 1, 2, 3, 4, 5, and just so that you know, you can keep adding more marks if you need to get this number line to extend out. And you can really start with, or you can also go in different increments. So maybe if you could start with 2 here, go 4, 6, 8. So it's really up to you, just as long as you label the numbers and note that 0 is in the middle here. Okay, so let's start with this. So -1 would be right here, and all I want you to do for that is to just put a little dot there, and then maybe right above here, just put your -1 right there. Okay, the next one I want to do is 2, so 2 is right here on the number line. I'm going to put a dot, label it up here. Next one I have is 5, put a dot, label it up here. 0, or our origin. And so we want to label the 0 right here too. Okay, moving on. -3 is right here, so I'm going to put a dot right here. Label it. Now -3.75. Okay, so we know that it's going to be -3 somewhere here, but we have that 0.75 attached to it. And so the way you can think about it is in two ways. So you can think about it this way. So we know that 0.75 is 3/4, okay? And so it's the same thing as calling it -3 and 3/4, so you can think of it that way. Another way, if you're confused about this 0.75, is think about how we have a dollar. So let's say we had $1. And how can I make $1 if all I had was quarters? I'd have to have 1/4, 2/4, 3/4, 4/4 to be able to make a dollar. So 75 cents would be 3 out of the 4 of these. Okay, so you just have to kind of guesstimate it, I guess, here on the number line. So let's say this is about the halfway mark, so another quarter might be about right there. So I'm going to put the dot right here and just label it on the top. Okay, so just guesstimate those decimals. We run into another semi-issue right here with 7/3. And so I would recommend, if you get a fraction like this and it's an improper fraction, to turn it into a mixed number. So that would look like this, right? So you can go into the 3 twice, so that's why the 2 goes in here, and then I have 1 left over, so the 1 goes on the top. So 2 1/3 would be about here. Here's about 1/3. Put a dot there, and then label it for me. And that's how we would finish that problem. So your whole answer would be this number line. And that's it. So just remember to put the dot and remember to label there. Something else I want to talk to you guys about is inequalities, and I think that this is appropriate for number lines. And basically there's symbols that we use to show the order of two real numbers. So maybe we're trying to see which one is bigger or smaller, we're comparing them, and so these inequalities are ones that you have hopefully seen or heard of before, but I want to go over them again. So the 4 main inequalities are the greater than, or a sideways V here, and it looks like this, it opens out this way. Okay, there's the greater than or equal to, which is the same symbol except to represent this equal to, we put a line right here. We have the less than symbol, and then the less than or equal to is the same thing, but you put a line right there. Okay. And so these are the 4 main inequalities that you see, and these are the symbols that go with them. And so we read inequalities from left to right. So let's say I wanted to compare the numbers 3 and 7. Okay. So 3 and 7 would look like this. So in this case, if I just kept the order and I just was going to compare 3 and 7 like this, 3 is, let's see which one fits. So is 3 greater than 7? Is 3 greater than or equal to 7? Is 3 less than 7? Or is 3 less than or equal to? So which out of these 4 fits? I would say this one. Okay, so I know that that's the symbol that's going to end up going in the middle. Okay, what if I flipped it? I did 7 and 3. Now which of these symbols match up here? The greater than, 7 is greater than 3, 7 is greater than or equal to 3, less than 3, or less than or equal to. Probably going to have to say greater than, so I'm going to write this in. So that's how we would write it. And a way that you can remember this is that when it's a less than, the small tip is pointing towards the smaller number, at this example, you see that the bigger or the open end is facing the bigger number, so this is going to end up being greater than, because the bigger opening is facing the bigger number, so it's greater than. Okay, and just so that you know if it was going to be a greater than or equal to situation, these two numbers would probably have to end up being the same. Okay, or if we were solving for maybe an equation or whatnot, we might use the greater than or equal to because we're not sure what the number is, so that might be an example of us using the ones that have the equal to on the bottom. So if the two numbers are distinctly different, you are not going to be using these ones that have the little lines underneath. Okay, the last thing I want to go over with you is absolute values. And so these are two situations that I want to give you. Okay, these two that I have here in the brown. And so the first one is this one. So the absolute value of A equals A. The absolute value of negative A also equals A. Okay. So scenario 1 and scenario 2. So what kind of conclusion can we draw about these two scenarios? What we can conclude from these two scenarios is that basically it doesn't matter if you stick in a negative number or a negative number or a positive number into an absolute value. No matter what, you're going to get something positive on the other end, right? Because in situation 1 I have a positive number in here and the end result was something positive, but in situation 2 I put a negative number inside these absolute value signs and the result ended up being also positive. So a way you can look at that is, sorry for this crookedness here, so a number that's inside a positive number inside an absolute value has a positive outcome, and it has also the same outcome as putting in something that has a negative. Okay, so it doesn't matter if it's a negative or positive number you're putting inside an absolute value, the answer is always going to be positive. And so let's look at some examples here. Number 1. So let's go step by step here. So we end up with a weird situation right here that we haven't seen yet in this course, where I end up with these two negatives here. So just to review, if you ever get a situation like this where you have two negatives like this, they cancel out and they end up becoming positive. So this negative 3 really means positive 3, okay? Plus, what do I know the absolute value of negative 7 is? So even though it's a negative number, it's still going to yield me a positive number. Plus the absolute value of 5 is 5. So I have 3 plus 7 is 10 plus 5. 10 plus 5 is 15. And we're done there. Okay, let's look at this one. I have a negative 15 in absolute value plus 8 times negative 3. So the tendency that some people want to do is they see this 8 times negative 3 in an absolute value and they want to distribute this and make this. But I don't want you guys to do that, okay? I don't want you to distribute first. And even though the answer is going to yield the same thing as if we distributed it or not, I don't want you to get into the habit of that because later on it's going to mess you up, okay? So what I do want you to do first is to solve all of these absolute values first, and then multiply at the end, okay? So the absolute value of negative 15 will give me positive 15, and then we end up with absolute value of negative 3 is 3. 8 times 3 is 24, and so we end up with 39 here. Last thing here, evaluate for n equals negative 8. Remember that evaluate just means substitute. So you're just going to drop down that negative and remember to place that n with a negative 8. And I'm actually going to leave the rest of the problem up to you to finish out so that you can practice. And then, of course, at the end of the video, you'll be able to see what the final answer of this is. So just keep watching or pause it. Thanks.